Now what we can do, we can replace the transistor with its AC equivalent circuit. That means we can replace this with its AC equivalent. You can say input you have the resistance and output you have the dependent current source, which can be shown as like this. You have a dependent voltage source AV into VI. Now I can write the output voltage VO as AV into VI into ZL upon ZL plus RO. How? By potential divider rule. Total voltage I know, AV into VI. This is your resistance RO and the other resistance ZL. This is ground. I want voltage at this point VO, so it will be ZL upon ZL plus RO multiplied by the total voltage AV into VI. So this I got by the potential divider rule. Now similarly we can find VF. Feedback voltage VF can be found as VO into Z2 upon Z2 plus Z3. How? In this diagram, if I want VO, or you can say VF, so the circuit will be, you have Z3, you have Z2, it is grounded. Here you have VO and voltage across this is VF. So I can write VF as Z2 upon Z2 plus Z3 into VO, that is the total VF considering by which potential divider rule. So the same equation I am using here, VF and VO. Now from this we can find the generalized equation, or you can say VF can substitute equation 1 in 2. So what we will have after substituting, you will get VO equals to AV into VI into ZL upon ZL plus RO and into Z2 upon Z2 plus Z3. So this part I have substituted for VO in this equation. So I have got this equation. So what we can say, this is VF. So VF upon VI is equal to AV into ZL upon ZL plus RO into Z2 upon Z2 plus Z3. Now what we can say, the amplifier gain is A and the gain of the feedback network is beta. So input for the amplifier is VI and feedback network what we are getting is VF. So the total gain can be written as A beta considering the feedback. So that is nothing but AV into ZL upon ZL plus RO into Z2 upon Z2 plus Z3. Now what we can do in this, this is our generalized equation. Now ZL upon ZL plus RO. We know ZL is nothing but Z1 into Z2 plus Z3 upon Z1 plus Z2 plus Z3. The whole divided by Z1 into Z2 plus Z3 upon Z1 plus Z2 plus Z3 plus RO. So after simplifying, this will get multiplied with RO and the denominator will get cancelled from both the sides. So what you are left with, ZL upon ZL plus RO will be Z1 into Z2 plus Z3 upon Z1 into Z2 plus Z3 plus RO into Z1 plus Z2 plus Z3. Now when substituting in their final equation, your A beta is nothing but AV into Z2 upon Z2 plus Z3 into Z1 into Z2 plus Z3, the entire term. Instead of ZL upon ZL plus RO, you can substitute Z1 Z2 plus Z3 plus RO into Z1 plus Z2 plus Z3. So this you got A beta.